All right, everyone. We are now on page number 95 of your student notes book, so you should take notes along with watching the video. Again, so this is page number 95. I'm sorry. So we're going to talk now about the stock nomenclature system, which is named for Alfred Stock. So this gets, I don't know, doesn't want to work my little clicker, of course, so hold on. Let me get my handy tool here. I'm not sure why this is not working either. Why aren't you working, my friend? Here we go. And we'll go here. Let's see if that works. Okay. So our stock nomenclature system, named for, not that you need to know this guy's name, but it's used with cations, and remember cations are positive, right, because we have pause. So cations are positive, right, and then these are going to be metals, right, because the metals are the ones that are the positive ions. To the left of the staircase on our periodic table back here. Okay, with two or more positive oxidation numbers. So from our periodic table unit, we know that the transition metals have more than one possible oxidation numbers. That was one of the characteristics of the transition metals, colorful solutions and multiple oxidation states. So the metals that are in the transition metals, so again, that's our center neighborhood here on the periodic table. Those are going to be have different numbers of electrons can be lost depending on the reaction conditions and what other elements we're combining with. So in order to differentiate, and so we know how to write a correct formula, because we have to know the charge to write the correct number, the correct formula, right? So we get the correct subscript. So we balance that charge out to equal 0, right? So all compounds are electrically neutral. So in order to do that, we're going to use Roman numerals, and we're going to use the Roman numerals in the chemical name to identify the positive charge of the cation. So the Roman numeral goes with the metal. And the Roman numeral is going to be the charge of the metal. It's not going to be how many of the metal there are. So we'll go for some examples, and we'll show you how that works. Sorry, too fast. It looked like happy with my clicker. Okay, so writing formulas with our Roman numerals. All right, so if we're going to go from our chemical name to our chemical formula, so we're going to have to match the name to symbol. So this is still the same like we did before. And did I go too fast? I think I might have. Hold on, let me just go back here for a second. No, I think we are just going to do the Roman numerals. Okay, so we'll just see. Chemical name to chemical formula, match the name to the symbol, and then we're going to look up the appropriate oxidation number, right? We did this when we wrote chemical formulas in our previous lessons. We looked at the reference tables and we figured out what is the oxidation state for the metal or the non-metal. So now those center ones in the center, right, the transition metals, there's more than one possibility. So we need a way to distinguish which one it is, because no two chemical formulas can have the same name. So we're going to look up those oxidation numbers, and the Roman numerals is equal to the positive charge, which again, the positive charge is most of the time going to be the metal. Almost all the time, at least definitely in this unit, we're just going to be talking about the metals for the most part. So now let's learn some Roman numerals. Okay, so if I have an I, that means Roman numeral 1. So in Roman numeral rules, you cannot have the same symbol more than 3 times in a row. So I means positive 1. 2 I's means positive 2. So now there's 3 I's, which is positive 3. So now I can't write 4 I's. So what I write is IV. V means 5. And since the I is to the left, so that means 5 minus 1. So that equals 4. So this is 1, and then this is 1 plus 1 plus 1, 3, 1 plus 1, 2. This is the Roman numeral for 5, so that just equals positive 5. Remember, again, this is the charge of the metal. So 5 plus 1, 6. 5 plus 1 plus 1 is 7, and there's just no such thing as a plus 8. Make sure you know definitely like 1, 2, 3, and 4. Those are going to be the ones that you're going to be more likely to see. And then again, just like we did before, we're going to crisscross to balance the charges. So we bring the, the oxidation state down to make a subscript. So the only thing different we're doing now is any metal that has more than one oxidation state, we're going to have a Roman numeral tell us what the oxidation state is, because there's more than one possibility listed on the reference tables. And there's no Roman numerals in the chemical formula. So what you have to do is you have to convert the Roman numeral to the charge of the metal, and you use that when you write the chemical formula. So now let's practice. So if I tell you chromium Roman numeral 3 oxide, this does not mean there's 3 chromiums. So it's going to be not 3 chromium atoms. And the 3 will not be the subscript. So subscript on the CR. But in a multiple choice question, that's probably the little dangly, tricky choice they're going to try to trick you with. So Roman numeral 3 means that the chromium is a positive 3. So I have to do symbols, write my symbols. So the symbol for chromium is Cr. The symbol for oxide tells me this is a nonmetal oxygen. So I have the +3 chromium, right? And then now I have my oxygen. What the heck is the charge of oxygen? You got to get the charge from the periodic table. There's only one charge for oxygen listed. So if there's only one charge listed, it's always the same, which is going to be, in this case, -2. So then again, symbols, charges, crisscross. So a +3 and a -2 have to equal positive number equal to the negative number, right? So I'm going to crisscross. I'm going to take this 3. That will become the subscript over on this side. Notice that the 3 does not go with the chromium. The 3 tells you the charge, so you can write the formula. It's not going to tell you the subscript. Oftentimes, it'll tell you the subscript on the other side. Not 100% of the time, like 90% of the time. So now we'll just do symbols, charges, crisscross, right? I have a +3 times 2, +6 total charge on that side. 3 times -2, -6 on that side. +6 plus -6 equals 0. That means my formula is legit. Now let's do another example. Manganese, Roman numeral 2, nitrate. So I have to get my symbols first. So Mn for manganese, careful, you want to make sure you use table S, because the symbol for magnesium is Mg. So make sure that you're using the correct symbols by checking table S just to make sure. The Roman numeral 2 tells you that the manganese is +2. It's not going to have a subscript of 2 next to this manganese. It won't be a 2, will not be a 2 here. So then the manganese is a +2. You have to write your own formulas based on the charges. So now nitrate, right? This matches table E from your reference tables. Right, so I'm going to go to table E. You write down, you copy down the whole thing for nitrate. I like to put this in parentheses, right, because just in case I need more than one. The polyatomic functions as one group. And so this is a -1 charge. So when I do my symbols, charges, crisscross, I need 2 nitrates, right, 2 of those -1 charged groups, and then 1 of the manganese. So now I have a -2 balanced by that +2. Notice that this Roman numeral 2 here is the positive charge of the metal. Notice it is not the subscript of the manganese. It actually ends up on the other side. Oops, sorry about that. So when we write our final answer nice and pretty, right, we have manganese, Roman numeral 2, nitrate. Because manganese lives in the center neighborhood. the transition metals of your periodic table, and it has more than one oxidation state, so you just don't pick one. You have to be able to write it using the correct oxidation state for the chemical compound that's been formed. So now let's look at sulfur, Roman numeral IV. So that's 5 minus 1. So that means that this sulfur is a positive 4. So now here we have a case where we don't have a metal. We have sulfur and we have phosphate. So we have a nonmetal and we have a polyatomic ion from table E. So on table E, the phosphate is a -3 charge. So that means that the sulfur has to be positive 4. And so I'm going to write my symbols, S for sulfur, and I'm going to write this with the charge being +4. So that's going to go right on top of sulfur, right? +4 sulfur. And now we've got the phosphate. You know how I always like to have a nice set of parentheses around a polyatomic because it indicates it stays together as a group. And so when you bring subscripts across, you bring it to the outside of the parentheses. So, and I have a -3 directly copied right from table E. Copied down the symbols for phosphate and the charge from table E. So now when you crisscross, I need 4 of those -3s, and I need 3 of those +4s. I'm sorry, I needed 4 of those -3s, and then I need 3 of those +4s, right? Because I have a +4, because this whole thing balances because of a common multiple here being 12, right? I have a +12 and a -12, oops, not 2, 12. And when I add those two up together, I have a legit chemical compound with my sum of my oxidation states being equal to 0. So then when I write my formula, making it look all pretty, again, notice that the Roman numeral 4 is not next to the element whose charge it represents. It ends up over here on the other side. And I did tell you that that works like 90% of the time. There are a few examples that it does not work. And I think we might have one coming up in the notes, but if we don't, then I'll just throw it in there. Right, so naming compounds. So now we went from the name to the formula. Now we have to go from the formula to the name, right? So formula to name. So the partner must have 2 or more different charges, the positive element, which is typically going to be the metal. And we have to match, of course, symbols to names. And we can crisscross to find the original charges. If there aren't subscripts, we're going to have to use the charges from the periodic table. And then we're going to assign the proper Roman numeral to the positive charge in the name, which again is typically going to be the metal, typically. Not 100% of the time, but most often the time. And we place that in parentheses, because remember, the Roman numeral tells you the charge of the cation. So let's take a look at our examples. So Fe2O3. So if I asked you to name this before I started talking about this Roman numeral stuff, you would say that's iron oxide. But okay, that's true, that's iron oxide, but so is this. Okay, well, you can't have 2 chemical compounds that have the same exact name. Every single chemical compound has to have a unique name, because you got to be able to put it in catalogs and chemical supply companies and ingredients lists and whatnot. So every compound has to have a unique name, which is where these Roman numerals come in. So I'm going to have to write down, so this is iron, right? So I have my word iron. And I have oxide, so we're going to reverse these crisscrosses, right? So this is iron oxide, but I need to know the charge of this iron. So this is where I do this reverse crisscross. So I know from the periodic table, oxygen's -2, right? So this is where that 2 went up. And I know from my reference tables, if you're looking, of course, you should have your own set of reference tables out as we go through, you know, notes videos, right? Because then you can reference it, and you can't, I'm sure you probably can't see this, but iron on the periodic table says +2, +3. Well, which one is this one? +2 or +3? This one's going to be +3, because I take this 3 and then that's going to go up there, right? So +2 and +3. So then this is iron Roman numeral 3 oxide, right? I translate iron. Now remember oxide, changing the ending. Now this tells me that iron has a +3 charge. Figured it out with math using the oxidation state from the periodic table, or reverse crisscrossing. Reverse crisscrossing works like 90% of the time. But if you know your charges, and you always are going to know the negative charge. Oxygen's always -2. It's not going to have another negative charge. You always have the negative charges on table E. So you'll have the negative charge. You just have to figure out the positive charge to get that Roman numeral. So here's that FeO. Well, this one's also iron oxide. So how is this possible? So this one's not as easy to do a reverse crisscross, because I'm not going to have, right, if I do this reverse crisscross here, then I'm going to end up with a +1 and a -1. But if I check my periodic table, oxygen isn't -1. So this is where this comes into place, to where knowing your charges comes in. Oxygen is a -2. So if oxygen's a -2, that means that this iron has to balance it out with a positive charge of +2. So now I have a legitimate chemical compound where the sum of the charges is equal to 0. So now this is not iron Roman numeral 3 oxide like the one above, because that was where iron lost 3 electrons. This iron, when it combined with oxygen in this chemical compound, only lost 2 electrons. So now we have, sorry, those are just the same thing I just wrote. Iron Roman numeral 2 oxide. Because remember, the Roman numeral tells you the charge, which is +2. Notice it is not the subscript. Notice in iron 3 oxide, it is not the subscript. I cannot emphasize that enough, because that is what a question is going to try to trick you in a multiple choice, is by giving you something like iron Roman numeral 2 oxide for this first question, and iron Roman numeral 1 oxide for this question, which is not legitimate. So now let's take a look at with something we have with our polyatomic ions. Can we reverse crisscross? Well, just double check if you can reverse crisscross. Check table E. The phosphate's -3. Does it look like reverse crisscross works here? Looks like it does. So let's take a look here. So if I reverse crisscross, that means the phosphate's a -3, and it means that the nickel is a +2. If the nickel is a +2, that means it's going to have a Roman numeral 2 in its name. Notice it does not have a subscript of 2 next to the Roman numeral, and it's more likely to be on the outside. So when I said the one on the outside works like 90% of the time, this iron Roman numeral 2 oxide is one of those cases because of the -2 charge from the oxygen. So that's going to wrap up our Roman numeral set of notes. We'll talk about hydrates in the next set of notes. Well, actually, I think I'm just going to I want to just do one more that you'll be likely to see. And I know I like to include this one on tests and labs if I can. Sometimes I do. It's like one of my favorites. So let me make sure that I have, so I like to do, oops, sorry. So MnO2. So let's try to give this one a name. So I need to make sure that I get my symbols and I convert those to words. So manganese, not magnesium. I always check table S just to make sure. And now I have oxygen, so oxide. Now, not every single element is going to need a Roman numeral. So this is where you have to decide, how well do you know your chemistry? Does this manganese need a Roman numeral? Check your periodic table. Look at the location of manganese. Manganese is right here, smack dab in the middle of the transition metal neighborhood. And it's got 4 different charges listed. Don't just pick one. You could also do a guess and check method. You could do that, but it's so much easier to go with what you do know for sure, which is over here, oxygen's -2 charge. So here's my -2 charge. If I reverse crisscross this one's one of those reverse crisscrosses that doesn't work. Because remember, elements combine in simple whole number ratios. So the way I like to do this one is with the negative charge. So 2 times -2, right? That's a total charge of -4. So if that's -4, negative-wise, then the manganese on the other side of this compound, of this formula, needs to have a total charge of +4. There's 1 manganese, total charge is +4. So that means that this is going to be manganese, Roman numeral 4, oxide. And then I'm just going to write one more down at the bottom, like the worst Regents question, one of the worst short answer Regents questions. I'd like you to write a formula for vanadium here. I'll just write it out and you just practice it and you try it. Okay, so at this point you should pause the video, try writing the formula for the compound with the name I just wrote on the screen here in purple, and then turn the video back on and check your answer. Or maybe I'm mean and I put this in an Edpuzzle and this is going to be like the last question or something on the Edpuzzle. Okay, so you should have unpaused the video. You should have tried this question on your own before, but you can always now watch me solve this question. So the year of this Regents exam, this was one of the short answer questions. So let's, write our chemical formula, symbols, charges, crisscross, and so I have symbols. I have V for vanadium, and I checked on table S, and it's V, and I have O for oxygen. Okay, now I need my charges. I know oxygen's a -2 charge because I've been doing this a while, and on the periodic table. And now vanadium is on the periodic table. Its symbol is V. Oh, look, did they give me the symbol or did they give you the charge? Interestingly enough, they gave you the charge. That means this vanadium is a +5. Of all of the elements they could have used, of all of the oxidation states, they tried to be tricky, and font selection matters too. So it wasn't written like this. It wasn't written that way. So if it had been written this way, more kids would have gotten the question right. Very few kids got that question right the year of this test. So now symbols, charges, and now I crisscross to balance the charge and get my subscript. So I bring my 5 across here, and I bring my 2 across here. And so I have V2O5 is vanadium, Roman numeral 5, oxide, right? Because we have a +5, 2 positive 5s is +10, 5 times -2, -10, legit chemical compound. So if you can do this one, and you can do this one, sorry, oh, I shouldn't have scribbled that out. That looks terribly messy. If you can do those two, I'm pretty sure you can do just about any Roman numeral question that you would ever come across on a test or quiz. Same thing for these two. Actually, iron Roman numeral 3 oxide and iron Roman numeral 2 oxide, very popular question banks. All right, so that wraps up our video. We're going to talk about hydrates in our next set. All right, until next time.